Hello everyone. Welcome to the course Advanced Manufacturing Technologies for Welded Structures. Starting today, we will study the methods of blanking and edge processing. In this lesson, we will learn together the basic knowledge of the shearing blanking method. The learning objectives of this lesson are as follows. Knowledge objective: to master the meaning of shearing blanking. Ability objective: to be able to select shearing equipment according to the material and to formulate a shearing process that ensures cutting quality. Quality objective: to cultivate a sense of standardization. The knowledge point of this lesson is shearing blanking. The key point is the adaptation of shearing equipment and the control of shearing quality. The difficult point is the control of shearing quality. There are many blanking methods for the boom, but in this lesson we mainly introduce shearing blanking. Shearing blanking is the process of cutting raw materials such as plates and profiles into the required blanks by means of shearing equipment, according to the requirements of parts or products. It provides precise blanks for subsequent processes such as stamping, bending, and welding. The processing objects are mainly metal plates, bars, and pipes, but it can also be applied to non-metallic materials, such as plastic sheets and composite materials. It is mainly used for low-carbon steel, easy to shear, few burrs. Stainless steel/aluminum requires special blades, anti-adhesion blades. The commonly used equipment is the shearing machine, which is classified according to the motion trajectory of the tool holder into straight-line shearing machines and circular shearing machines. 1. Straight-line shearing machines. Suitable for straight-line shearing, economical and efficient. 2. Circular shearing machine. Used for processing curves or strip materials. Types of shearing machines and tool parameters are as follows. 1. Types of shearing machines. 1. Mechanical type. Suitable for thin plates, high speed. 2. Hydraulic type. Suitable for thick plates, stable pressure. 2. Tool parameters. 1. Blade material. CR12MOV for carbon steel, cemented carbide for stainless steel. 2. Adjustment of blade clearance. It is usually set at 5% to 10% of the material thickness. For example, if the plate thickness is 12 mm, then the blade clearance is calculated as 12 times 5% to 10% equals 0.6 to 1.2 mm, with 1 mm taken as the actual value. How is the quality of the cut controlled? Let us now study this together. 1. Burr suppression. 1. Maintain blade sharpness, where less than or equal to 0.1 mm. 2. Adjust the clearance properly. If the clearance is too small, burr height will be excessive. If the clearance is too large, edge collapse will occur. 2. Verticality deviation. 1. Parallelism error of upper and lower blades less than or equal to 0.02 mm. 2. When shearing thick plates, increase the pressing force, greater than or equal to 3 times the weight of the material. How is material deformation controlled? Let us continue to study further. 1. Bending deformation. 1. Cause: uneven release of shearing stress. 2. Countermeasure: use a multi-point pressing device or perform post-treatment with a leveling machine. 2. Twisting deformation. 1. Thick plates, greater than 6 mm, are prone to twisting. 2. Optimize the shearing sequence. Segmental shearing from the center to both sides. Next, let us study the meaning of the model designation of a gantry shearing machine. Table 2.6 shows the technical parameters of the shearing machine, mainly including model, shearing dimensions, shearing stroke, number of shear reciprocations, back gauge adjustment range, overall dimensions, length times width times height, shear angle, pressing force, blade length, and power. We then proceed to study the maintenance and safe operation specifications of the gantry shearing machine. 1. Familiarize yourself with the structure and performance of the shearing machine. 1. Check whether the oil level in the oil tank reaches the specified level. If the oil is deteriorated or unclean, it should be replaced in time. Check whether there is leakage in valves and pipelines. Check whether various instrument displays are functioning normally. 2. Conduct an idle test run. Carefully check whether the control devices and the operating state of the shearing machine are normal. 2. Pre-start inspection and test run. 1. Check whether the shear blades are sharp. If damaged, they should be replaced in time to avoid dragging of the blade, as shown in Figure 245. 2. Clean the surface of the plate. Check the surface quality of the plate, and check whether the shearing line is clear and correct. If there are hard foreign objects on the steel plate that affect shearing, it must not be sheared, as shown in Figure 246. 3. Adjust the clearance between the upper and lower shear blades according to the thickness of the sheared plate. The specific values can be obtained by consulting the table. 4. After cleaning the surface of the steel plate, place it on the work table of the shearing machine and start the machine for shearing. 5. When shearing a large number of plates of the same specification and size, continuous cutting can be performed with random inspection of part dimensions. 6. When shearing different shapes of parts from the same plate, the shearing sequence must be considered in advance, as shown in the figure. 7. When shearing narrow strip material, if the pressing device cannot hold down the plate, auxiliary methods such as adding pads must be used, as shown in Figure 14. In the figure, 1. Pressure position. 2. Plate to be sheared. 3. Pressing plate. 4. Backing plate. 8. After the cutting work is completed, clean the workstation. Next, let us study the task of cylindrical shell shearing blanking. The shearing blanking dimensions of the cylindrical shell are as shown in the figure, where 1 and 2 are the shearing lines. The operating steps for cylindrical shell shearing are as follows. 1. Familiarize yourself with the structure and performance of the shearing machine. 2. Pre-start inspection and test run. 3. Add lubricating oil. And, according to the plate thickness delta equals 8 mm, adjust the shear blade clearance to 0.35 mm. See Table 27. 4. Perform shearing work. 5. After use, cut off the power supply. Clean the burrs of the sheared parts, arrange them neatly, and clean the work site. 6. Quality inspection. 1. Visual inspection. 2. Dimensional inspection. Everyone, in this lesson we have studied the basic knowledge of shearing blanking. I hope you can master the knowledge learned in this lesson and apply it to practical life and work.